This video is going to cover the third page of the Chapter 3 test, version 2. And we're told in this first question on the page to solve for x in the diagram below. And we're given a big hint: use one or more auxiliary lines. So there's several ways that you can do this. The most popular way that I saw was students would just take their parallel lines, make them a little bit longer, this, and then extend their transversals. So just taking this transversal, making it a little bit longer, and then same thing here, make this a little bit longer. And if you can, making triangles is really powerful because we know that triangles add up to 180 degrees. Okay, so let's fill in what we can. A lot of people saw that, you know what, hey, here's a straight angle, 145. And the angle adjacent to it here would make 180 degrees. So what's this measurement here? Well, that would be 180 minus 145, which leaves us with 35 degrees. So I can fill this in. What other straight angles do we see? Well, we see that x is going to make a straight angle with this unknown here, but I don't know x yet. So what about 118? What can I do with 118? Well, I'm already starting to fill in this bottom triangle. So is there anything I can do with 118? Maybe down here where the transversal cuts the other parallel line. Well, 118 and this angle should be supplementary. Why do I say supplementary? Well, they're same side interior angles. Okay? Although some of you went straight over to here because you're more used to alternate interior being congruent. This is 118 through alternate interior, and this must be 62 degrees because 180 minus 118, 62 degrees. All right, now I know that this is 35 and this is 62. Many of you are probably going to say, hey, I can figure out this angle here, because there's 180 degrees in the triangle. 180 minus 35 minus 62 leaves me with 83. There is an even faster way to get to x, though. We hopefully remember that in a triangle, and I'm considering this triangle at this point, any exterior angle is going to be equal to the sum of the two remote interior angles. Okay? So we can actually say really quickly that x is equal to 35 degrees plus 62 degrees using that theorem. 35 plus 62 gives us 97 degrees, so we're done. 97 degrees. Now I want to show you one or two other ways that people solved this problem. I'm going to erase the work that I did. And one thing that you could do was add another transversal. One way that people did that was to cut the transversal at a very particular angle, 90 and 90. Why would they do that? Well, they knew this formula, which tells us the sum of interior angles in a pentagon, or any polygon for that matter. So they knew they could figure out 5 minus 2 times 180 should give them 540 degrees. The whole pentagon should be 540 degrees. And they knew that they would get that by adding 118 plus x plus 145 plus 90 plus 90. Solving for that gave them x equals 97. And really, you could create lots of polygons. I saw one student chose to make a hexagon. So, like this, and then use this formula, but for a hexagon instead. We'll move on to the next and final problem. We're given this diagram where two parallel lines are marked. Then we've got a couple of pieces of information. We've got this is 50, this is 70, and this is 2x squared minus 3x. So a variety of ways you could have gone about solving this problem. Okay. Some people notice that 50 degrees would be alternate interior with this angle here. This is 50, this is 50. And then they also noticed that 70 degrees made a straight angle with this missing third angle and a triangle. So 180 minus 70 gives them 110. And they chose to add up 2x squared minus 3x plus 50 plus 110 gives them 180 degrees. Simplifying that, we get (2x squared minus 3x equals equals 20. Okay. Now, is there any other way to find that information maybe a little bit faster? Well, if you recall that theorem about, it's really a corollary of the triangle sum theorem, where the exterior angle of a triangle, and the triangle that I'm talking about right now is here. The exterior angle of a triangle, I'll call 70 the exterior right now, is equal to the sum of the two remote interior angles. Okay, so this angle and 50 should add to 70. What plus 50 gives me 70? Well, 20 degrees. Okay. And then what do you notice about 20 and 2x squared minus 3x? Well, those are alternate interior, and don't we know that alternate interior angles are equal? So there we'd get 2x squared minus 3x equals 20, which is exactly what I got the other way. So however you got to this quadratic, you want to make sure that all terms are on one side and 0 is on the other before you start to solve it. Now this is actually factorable, but most students don't like to factor when the a term is not 1. So we're going to go ahead and use the quadratic formula. So a equals 2, b equals -3, and c equals 20. And the quadratic formula, as you'll recall, negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b would be -3 or a +3. Got to square that b. A is 2. C is -20. All over 2a, or 2 times 2. I'll just clean this up. We get 9 plus 160. And the square root of 169 is 13. So 3 plus or minus 13 over 4. Don't stop here. 3 plus 13 is 16 over 4, but 3 minus 13 is -10 over 4. And those reduce to 4 and -5/2. And then at this point you want to check both of those answers back in the problem. Make sure that when you plug them in, you get 20 degrees. Now, I think many of you, sorry about that, would immediately circle 4, but might think, hey, -5/2, it doesn't make any sense, a negative. But when you do plug -5/2 in, it does work. If you notice, we're going to square the x here, so the negative would go away, and then minus 3x, that'll be a negative times a negative, which will also yield a positive. So -5/2 or -2.5 will work. And that concludes this video.